continue a little bit with 5.2. Let me just do a couple examples. I don't even think I have to go over this as far as like teach you how to do it. We'll just do a couple examples and should be good to go. So this is what we kind of did this yesterday, but we concentrated more on the graphing of it yesterday. This time we're just going to plug some numbers into the functions. It's really not much different than stuff that we've done before. 1/4 to the x. Okay, so here you got two functions. You got an f function and a g function. What do you think they're going to do? They're going to tell you find f of a number. So they're going to say find f of 2. All right? So what do? You look at these two functions. Here's the f function and here's the g function. And you're going to take the 2 and put it into which one? The f function, right. And where are you going to put it? Put it in for that x right there. Okay, so what do we get? We get 3 to the x. What goes in the place of the x? A 2, right. It's just a substitution is all it is. All right, and then you just work that thing out. 3 to the second, or 3 squared is 9, and that's your answer. Pretty easy, isn't it? All right, what if I give you another one? What if I said g of, let's put I'll put a positive. Let's go, I'll just put a 2 in there again, okay? So let's go g of 2. So what do? You look at the g function, and then you put that 2 in for the x in the g function. So let's see how we do that. It's 1/4 to the what? To the second. And how do we do that? 1/4 squared. Well, we take 1 squared, right? We take the top to the second power, so 1 squared is 1, and then 4 to the second is what? 16, and there's your answer. It's 16. Let's do another one. Let's say g of -2. What if I put g of -2? Well, it's 1/4 to the what? -2nd. We did this a while back. I think we might have mentioned this a little bit yesterday too. If I take this to a -2nd power, negative power, and this is a fraction, what am I going to do with that? I'm going to flip it, right? So instead of 1/4, I'm going to make it 4. Instead of to the -2nd, I'm going to make it to the +2nd. Everybody see that? So this negative exponent, you flip this, and you change the sign of your exponent. So I flipped 1/4, which is a 4, and then I changed the sign of the exponent, which is a 2, and that's 16. Make sense? All right, that was pretty easy. So you got a few problems on here like that. We'll probably have to continue this next part, but at least you'll be able to do some of this worksheet. You'll be able to do about half of it. Let's see how many I gave you. I gave you 16 problems. You should be able to do the first 7 problems, but we got about 10 minutes, so let's begin. I don't know if we'll be able to finish this, but let's at least begin the next little part of this. We're actually going to solve for x this time. We're not just plugging numbers in. We're actually going to solve an equation, but we're going to have our variables in the exponent, and we're not used to that. I don't think you've ever, I don't even know if even in Algebra 2, you might have done it in Algebra 2, I can't remember, actually solved when you had a variable in the exponent. So let me flip around here, find some examples. Where are they? Flipping. Alright, here's one. Let's do like this. Now there's a few little tricks, so you really want to write these things down. If you just sit here and just watch me, you're going to forget all these little tricks. So it is a good idea to write this down. So here's an example. I got 4 to the x equals 2. Alright, and man, I wish I could see in the book where this applies. Oh, there it goes. It's kind of hidden in there. Let's see if they give you a property. They sure leave out a lot of stuff in this book. That's the way with college books. They don't necessarily give you every little detail. They leave some things out. And you're used to, in a high school book, them giving you every little detail. But let's do this. What we're going to do is we want to solve for x. We want to go 4 to what power is equal to 2? Well, let's think about it. What about a 1? Could this be a 1? No, because what? 4 to the first equals what? 4. Could it be a 2? No, because 4 to the second equals 16. So guess what? Give me a general idea where you think that number is going to be. You think it's going to be more than 1? It's going to be less than 1, isn't it? What if it was a 0? What's 4 to the 0? It's a 1, isn't it? So x is probably going to be somewhere between what? 0 and 1, because 4 to the 0 is 1, right? 4 to the first is 4. 2 lies in between that, doesn't it? So it's probably going to be somewhere in between. It's probably going to be a fraction, right? All right, so let's think of what we're going to do here. Here's a little rule. If I had this, if I said a to the x power, let me think of how I want to say this, equals a to the y power. See this? If these two are actually equal to each other, this base a is the same base as this right here. What must be true about x and y if we have a situation like this? It's got to be equal to each other, right? Because a to a certain power, for instance, if I said 3 to the second equals 3 to the y. You follow me on this? Because 3 is the same base. It's kind of like your a, isn't it? Watch. 3 to the second power equals 3 to the what power? 3 to the second power, right? 3 to the second equals 3 to the second. So what must be true? Y must equal what? 2. You follow me? So if you have the same base and they're equal to each other, guess what you do with your exponents? Nobody? What are you going to do with your exponents? What did I do to that 2 and that y? Set them equal to each other, right? Made them equal. Do you not see that, or are you just not talking to me? Okay, so if I have the same bases, right, the same base, what do I do with the exponents? I set the exponents equal to each other. So 2 equals y, or y equals 2. What are we going to do here? Do we have the same bases here? No, we don't. This is a 4 and this is a 2. So here's the trick. What we're going to do is we're going to try to write it so that we do have the same bases. I want to take that 4 and I want to write it so that I have a base of 2. How in the world, and they've rigged these problems for you, okay? It's not they didn't just put random numbers in here. How in the world could I change 4 into a number with a base of 2? What would I write that as? 2 squared. Good. 2 squared is the same thing as 4, isn't it? Okay. Now that 2 squared is being taken to the what? Oops. I said 4. To the what power? To the x power. Would you agree this and this is exactly the same thing? Yeah. And that's equal to 2. Now watch this. Let's do this one more time. Watch. 2 squared to the x. What's the rule when you have an exponent taken to another power? Just multiply it together, right? Remember that? Look it up if you don't remember it. So 2 to the 2x is equal to 2. Now look what we have. We have that situation where we have the same base, don't we? And that's the key to these problems. Not every one of them, but a lot of these problems, you want to try to get the base to be the same. Sometimes you can, sometimes you can't. On this one, we can. Okay? So I want to get the bases to be the same. Now, what do I do with the exponents? If the bases are the same, what did I say is true about the exponents? They're equal to each other. I don't even see an exponent over here, though. What would the exponent be? To the first. Right, 2 to the first. It wouldn't be a 2. 2 to the second's not 2, is it? 2 to the first is 2. So watch, the bases are the same, so what do I do with the exponents? Set them equal to each other. And now I can solve for x. Divide by 2, divide by 2. X is what? A half. Remember we said x is probably somewhere between 0 and 1? Well, it's exactly between 0 and 1. It's halfway in between. Alright, so x is 1/2. Let's see if that makes sense. 4 to the 1/2. What does that mean, 4 to the 1/2? If I take something to the 1/2 power, that means the same thing as what? Remember any of this? The square root of 4, isn't it? What's the square root of 4? It's 2. So does it work? Absolutely. 4 to the 1/2 is the same thing as 2. So that works. Yep. Right here? I can't hear you.
Why did you make it 2x?
Because I had to get x by itself. It's just basic algebra 1. 2x equals 1, right? I got to get x by itself. 2 is being multiplied by x, so I divide by 2.
So
You're thinking too hard because that's a real basic algebra principle. You know how to do that. So when I get 2x minus 1, do you understand how I got 2x minus 1? Is that what you're asking, or you're asking how to get from here to here? How did you... So how did you get from here to here? Okay, all right. You knew how to get from here to here, though, right? Okay, gotcha. We use this rule right here. When the bases are the same, right? When the bases are the same, what do we do to the exponents? we set them equal to each other. So look, these bases are the same, right? They're both 2. So what did we do with this exponent and this exponent? We set them equal to each other. Right? Just like we did up here. We said 2 equals y or y equals 2. All right, we did the same thing, except this is 2x. This exponent is 2x. This exponent is 1. We set them equal to each other, and then we put it right here, and then you just divide it by 2 and solve for x. Let's do another one like that. If I can find one. Let's do one a little bit more challenging, but it's basically the same kind of thing. Watch this one. 2 to the x plus 4 equals 8 to the x minus 6. Again, look at the bases. Are the bases the same right now? No, they're not. So I need to change one of them. Which one do you think I'm going to change? The 8. And I want to change that 8 so it has a base of 2. So what do I want? I want 2 to the something power. What is 2? 2 to what power is going to give you 8? 2 to the third, right. 2 to the third is equal to 8, isn't it? So let's write it like that. Now, I didn't do anything to this side, so I'm going to keep that the same. Watch, I'm going to take that 8 right there, and I'm going to rewrite it 2 to the third. That's the same thing as 8, isn't it? And I'm going to take that to the x minus 6 power. Now I'm getting a little closer, because now I got the same base, don't I? All right, and that's the key to some of these. Not every single one of these problems, but some of these, the key is to get them to be the same base. So what do? It's 2 to the x plus 4 equals. Now, what's the rule? We did this in the last problem. What's the rule when I take a power to another power? I multiply them together, don't I? So it's 2 to the what? So I have to multiply them together. So if I multiply them together, I get what? 3x minus what? 18. Now watch. The bases are the same, so what do I do with the exponents? Set them equal to each other, and I'll let you do the rest. X plus 4 equals 3x minus 18. And then you can do the work and then solve for x. Okay? Let me give you a worksheet. Try them. Try as many as you can. You might be able to do the first. You might be able to do the first page. It looks like you could probably do the first page. Okay? And then we'll work on the other ones on Monday.